Okay, guys, so the Mole Vodcast 2. Today we're going to be talking about the molar mass. And so let's get started on calculating molar mass. What is molar mass? Well, simply put and easily defined, it is the mass in grams of 1 mole of a substance. So if I had 1 mole of something, how much would they weigh? It doesn't matter what it is. How much would 1 mole of it weigh? And that's what the molar mass is. And so the molar mass is expressed in units of grams per mole again. So how much in grams on the top would something weigh, would 1 mole, so per 1 mole, weigh? So that's what the units are for molar mass. How do we know or calculate the molar mass of elements and compounds? Well, let's take a look at that. And so the atomic mass of carbon is 12.011 AMUs. How do you know that? Well, if you take a look at the periodic table and you looked at carbon, you would see that its atomic mass is 12.011. We learned about that earlier. And so that is expressed in AMUs as the atomic mass. And so the atomic mass of carbon is 12.011 grams. Or I'm sorry, AMUs. Well, the molar mass of carbon is the same number in the unit of grams, 12.011 grams. So if you had 1 mole of carbon atoms, then they would weigh 12.011 grams, or 12.011 grams of carbon per 1 mole of carbon. That would be an important thing to know. Not just this particular one, but that's how it works. That it's the grams of the substance per mole of the substance. And so that is the how you just get off the table. It's really easy. Just go to the periodic table and find the mass. And so let's calculate the molar mass of some compounds. What is the molar mass of carbon dioxide, CO2? Well, here's what you do. You just add up the different elements. It's no more complicated than that. And so we'll go and we have 1 carbon atom. And so once again, if you go look at the periodic table and you look at carbon, the mass of carbon is 12.011. And so we have 1 of those because the formula has 1 carbon in it. So 1 times 12.011 equals 12.01 grams. We have 2 oxygens, and so again, go to the periodic table. If you look at oxygen, the molar mass of oxygen is 15.999 grams per mole, but we have 2 oxygens because the formula tells us we have 2. So we'll take 2 times that number. 2 times 15.999, that gives you 31.998. You take those 2 numbers, you add them together, and you get 44.009, and that's going to be in units of grams per mole. You could write this, and it would probably be more effective and easier if you wrote this as 44.009 grams CO2 over 1 mole. And you can put the unit here, CO2, as well. That would be a more precise unit, if you will. This many grams of carbon dioxide in a mole of carbon dioxide. And so that wasn't too bad, was it? Not too shabby to do that. Let's take a look at another example. What is the molar mass of aluminum chloride? Uh-oh, I did not give you the formula. I'm going to make you find out what the formula is. Well, that's easy enough. This is an ionic compound, right? Aluminum is a metal, and chlorine or chloride is a nonmetal. That's ionic, so we're going to look at charges. So aluminum and chlorine. If you go to the periodic table, what's the charge of aluminum? Well, aluminum is in this column right here. Remember that column right there is a 3+. If you look at the chlorine's in this column here, and that column is a 1-. And so if we go back, we'll get a 3+ on the aluminum, a 1- on the chlorine, and then at that point, remember, you crisscross your charges, and you get a formula of AlCl3 for aluminum chloride. All right, so now let's do our masses. We have 1 aluminum. All right, go back to our periodic table, find aluminum, and it has a mass of 26.982. So we have one of those. 1 times 26.982 gives us 26.982. We have 3 chlorines. So go to your periodic table, look up the mass of chlorine, 35.453. We have 3 of those, so 3 times 35.453 gives you 106.359. Add those together, and you get the total, 133.341. Again, the units would be grams of aluminum chloride per mole of aluminum chloride. I would prefer, and I should have made the PowerPoint this way, I would prefer you to write this as AlCl, grams of AlCl3 over 1 mole of AlCl3. That'd be my preference for you to write this. I should have changed the PowerPoint, but I didn't. And so let's continue. I think I've got one more example for you. Yeah, what's the molar mass of iron 3 sulfate? And so iron, Roman numeral 3 again, and sulfate is SO4. So what's the 3 mean? That means iron is a 3 plus. Sulfate has a charge of 2 negative. Do your crisscross there, and you get Fe2 SO4 in parentheses with a 3 on the outside. A little more complicated, but still not too bad. So we have 2 iron atoms. Let's go to our periodic table. Find iron. It's atomic number 26 right there. 55.845 would be your atomic mass of iron. Go back. You have 2 of those. And so 2 times 55.845. If you look at sulfur in the formula, there's 1 here, but this 3 gets distributed to both that 4 and the 1. So we don't have 1 sulfur, we have 3 times 1 sulfur, or 3 sulfurs. Oh, forgot to do the mass there. 111.69 for the iron. So we have 3 sulfurs. Go find sulfur on your periodic table right there with a mass of 32.066. We have 3 of those. 3 times 32.06. Oh, I left off a 6 there. 06. And we get 96.18. And then we're going to look at our oxygens. Again, this 3 gets distributed to what's inside the parentheses here. So we have 3 times 4, or 12 oxygens. And go to our periodic table and look up oxygen. And we have a mass here of 15.999. We have 12 of them. So 12 times 15.999 equals 191.988. You're going to add up those. We get a total mass of 399.858 grams per mole. Once again, my preference would be that you would write this as 399.858 grams Fe2SO4 3 per, and put that all over 1 mole of Fe2SO4 3. Okay, and so that is, that is my preference on how you write those, not just the gram/mole on the right side of the number, because in our conversions we're going to put it over like that. Some technicalities. Let's talk about some technicalities. Because you may or may not see these in my class, or maybe on some standardized tests, or in college. You'll see these as well. The molar mass is the mass of 1 mole of some substance. Now, the names of the particle of an element is an atom. So if you have an element, the smallest part of that element is the atom of whatever that element is. If you have a covalent compound or molecular compound, such as water or carbon dioxide, then the smallest part of that's a molecule of water, a molecule of carbon dioxide. If you have an ionic compound such as salt, then the smallest unit, if you will, of that salt is called a formula unit. So NaCl is a formula unit of salt. Salt is really this big giant matrix of hundreds and millions of atoms, but the ratio being 1 to 1 is the important thing, and that ratio being 1 to 1 is the formula unit. So technically, The molar mass of an element is called the gram atomic mass. It's the atomic mass in grams, which makes sense. The molar mass of a covalent compound is called the gram molecular mass. It's the mass of the molecule in grams. And the molar mass of an ionic compound is called the gram formula mass. It's the mass of the formula unit in grams. However, I don't use the term gram atomic mass, gram molecular mass, gram formula mass in class. I just don't speak in those terms. I just use the term molar mass, which is kind of encompasses all of those. So if I say the molar mass of and I'm talking about the molar mass of, let's say, carbon, well, you just go to the periodic table and look it up. Technically, it's the gram atomic mass because carbon's an element. If I say, hey, give me the molar mass of water, well, technically, you're looking up the gram molecular mass because water is a molecule, a covalent compound. If I say, give me the molar mass of salt, technically, you're looking up the gram formula mass. Molar mass encompasses all of them. I'm not picky on you using gram atomic mass, gram molecular mass, gram formula mass. However, I wanted to give you a heads up because you do see that out there sometimes on standardized tests and other places. But I generally just use the term molar mass. Sometimes I use the term molecular mass because we deal with molecules a lot. It doesn't really matter. If you're asked to find molar mass, molecular mass, do what we just did in the examples. Okay? So work on some of those practice problems, and then we will see you next time.